Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question extracted from 2017 November, which is time zone 0, multiple choice question number 1, asking for the concept related to stoichiometry or the so-called number of moles, right? So the concept is rather easy. It's actually asking for a definition of what is meant by number of moles. So let's record. Remember, number of moles is actually defined as equals to the number of units divided by our Avogadro constant, which is 6.02 times 10 to the power 23. Actually, this is the really fundamental definition that how we define one mole and why scientists develop the concept of moles, right? Yeah, a lot of students actually don't pay so much attention to the first definition, or we can say the first equation in calculating mole concept. Yeah, so remember, actually, it is going to be tested even in the first question, right? Let's see. They're asking how many atoms are there of nitrogen, and are there in 0.5 moles of this ammonium carbonate, NH4 bracket 2 CO3, which is really straightforward. That means now we are asking for the number of units, and in this case, the unit is going to be atoms, right? And given the moles, right, which is going to be 0.5, right? But the point is, if students just think directly that, 0.5 is the number that we plug in here, and so multiply the 6.02 times 10 to the power 23 to the left-hand side, so we get the answers. So this is wrong. Why? Because as you need to recall, the number of units that I put here and the number of moles actually here also bearing a unit behind here, which means behind number of moles, it can be describing number of moles of molecule or number of moles of any other unit, right? And always, as always, the testing point of this kind of question is that the unit behind here and the unit behind the number of moles is going to be different, exactly like this question, right? What they're given is 0.5 moles of ammonium carbonate. Ammonium carbonate exists in the formula of this ionic compound, right? So this is going to be number of moles of this full unit. But what they are asking, are they asking for the total number of this full unit? How much? No. Instead, they're asking for the number of atoms of nitrogen within this whole unit. So that means, first of all, we must be so clear about the unit. Let's make them to be coherent before multiplying the 6.02 times 10 to the power 23, right? As we know, given, let's say, maybe I'll use this to be starting. 1 unit, let's say, 1 unit of NH4 bracket 2 CO3. Now we know that every unit of this ammonium carbonate will have 2 units of nitrogen, right? You can see that what I'm doing now is try to convert the whole formula into specifically the number of nitrogen, because this is what we're looking for, right? So as we know, 1 unit of this whole formula contains 2 units of nitrogen, because from the formula, ammonium has a bracket 2. So that's why we have 2 nitrogen in each of the formula. So now if we change the noun form, so 1 mole of NH4 bracket 2 CO3 will have then 2 moles of nitrogen. So in this case, the nitrogen will be the nitrogen atoms, right? You see, I'm now switching the unit from the entire formula to just the number of atoms, right? So now I'm switching the unit. So that's why now they're given, right? 0.5 moles of this NH4 bracket 2 CO3, so which means now I'm having 1 mole of nitrogen, right? The same logic, right? Because always be the factor of 2. So that's why this 1 mole of nitrogen is it. You see, now I'm switching the channel from 0.5 moles of this entire formula to 1 mole of nitrogen. So now you see my unit now switched to nitrogen atoms. So if I now having the unit now coherent with what I'm finding, also that number of atoms of nitrogen, right? So now I can simply multiply the 6.02 to the right hand side. So that's why by these 1 mole of nitrogen atom is the number that I plug here. So that is 1. And so my question mark is going to be on the right hand side, the numerator. So that's why the answer will be 1 times 6.02 times 10 to the power 23. If you want to get to know the equation will be like that, right? The number of units of nitrogen atoms in this case will be equal to, starting with 0.5. But you know, 0.5 is the most referred unit knot we are finding, right? But the factor is going to be multiplied by 2 because 1 unit of the formula contains 2 units of nitrogen, right? So 0.5 moles of this full unit contains 1 moles of nitrogen. So now we make the unit coherent. What I'm now finding is number of atoms, and what we are now having is 0.5 times 2 moles of atoms, right? So same unit. So at the end, times the 6.02 times 10 to the power 23, right? So obviously the answer is going to be D.